In this podcast, we will talk about some of the greatest technologies that exist today, like robotics, drone technology, simulation, self driving cars, the humanoid robots. I believe that in the future, we will be using all these technologies, the robots in our everyday life. Already, we have started doing it with the use of robotic mowers in our gardens, and they will very soon also come to our homes, assisting us in different work, uh, different repetitive work that we are doing, so that we can focus on much better things in life, which is like thinking about how to make ourselves more healthier, thinking about spending more time with our families, and creating a better world by creating more jobs. So this is the reason why it was very important to discuss with a roboticist as to what they think about how robots, and especially the ones who are getting intelligent nowadays, will change and shape our world. Hope you will enjoy this podcast. And if you do, please do like, subscribe, and share this podcast with your network. As a podcast host, I need this support from you. Also, on our YouTube video, please do not forget to subscribe and hit the bell icon so that you are subscribed and you're notified of the videos that we upload on our podcast. Hello and welcome to the Sci-AI podcast. This is episode number 32. Today, my guest is Julia Nitsch. Julia is a roboticist focusing on the perception of autonomous robots. She has worked on multi-modal perception and machine learning algorithms for a long time. She also has a PhD, and it is my pleasure to invite her on the podcast. Hi, Julia, how are you doing?
Thank you, fine. I'm looking forward to our discussion.
Okay, great. So, Julia, my first question is, as we all know, drones are in many practical aspects, including military warfare, drug delivery, and much, much more nowadays. We all know that drone technology is taking us by storm for almost a decade now. Um, how does then machine learning create models and opportunities for the unmanned aerial vehicles like UAV? Um, and also, if you can talk about the use of deep convolutional neural networks, the role of them in visual perception.
Sure. So, yeah, when we're talking about this unmanned aerial vehicle and especially in the delivery field, so what we actually want to achieve, or where I see the biggest benefit of these drones, is when we can really deliver goods to remote locations, maybe also in an urgent case, like we need to deliver medicine. And sometimes we don't have the opportunity to have for each drone a single pilot. So we really need to go to a stage where the drones can fly as autonomous as possible, and that's where I see the big benefit. And for this stage, especially for this autonomous stage, we need a good environmental perception. So the drone simply needs to understand where it is, from what it is surrounded. And for this, we have simply the opportunity with different sensors. And as you said, one of them could be a camera. With a camera, we can perceive the whole environment, detect objects, and yeah, especially when it comes to perceiving the environment and object recognition, we currently see that neural networks, and in particular CNNs, are simply state of the art for this object recognition task. So that's for me really the big benefit, where we can apply them. In particular because we know most of the times which objects we can expect, where we don't want to fly into, where we need also to perceive our landing zone, so that we can do a safe landing and a safe delivery. And that's where neural networks and CNNs play a big role for these objects.
So, how about the use of machine learning to create models and opportunities for UAVs?
Yeah, so as I said, CNNs are yeah, a big topic in object recognition. Of course, what we need
Right.
to do is always running the complete machine learning pipeline. So we need to collect our data, we need to yeah, record our own data sets, because for the drones it's yeah, different to normal cameras, so we have simply a different perspective of the objects, which are not that much
Mm,
present in other data sets. So that's why we run for the complete data collection pipeline, data cleaning pipeline, making sure that we have a broad data set of what we need. This is the first step, of course. Another big topic is also using data from simulated environments so that we can enlarge our data sets with also simulated data, and yeah, running some computer vision techniques or also neural networks on it so that the data gets more similar to our recorded data. And then we can really start on defining the objects, training object recognition models on it. Of course, when we are talking about object recognitions, we are talking about also refining existing models. So sometimes it's necessary to train models from scratch, so without any preset parameters. But I think, especially for object recognition, it makes a lot of sense to go to the refinement and the retraining instead of starting from complete scratch. One important aspect when we are talking about machine learning, not only the learning of the models and the creation, is also the deployment. So we have to imagine this is not a server which is flying out there in the air.
right.
So we really have our autonomous robot. We have usually embedded hardware, which is
Right.
not as powerful as yeah, as your laptop, which you can use. So this is one big aspect. So these models also need to be really targeted for the execution hardware. And of course, one big topic of drones is always the battery life. So this is something, it's always a trade-off between the computational expense which we can afford and the terms of battery life. So this is, I think, for all the autonomous robots the same. Will probably become also a big topic when we are talking about electrical cars. But this target platform where we really execute the things, so we can't just use anything. We really need to take care of what we want to deploy and where the benefit lies in terms of computational costs, in terms of yeah, expanding the lifetime or the runtime of our drones.
That's a great point. And the battery aspect of it, I'm pretty sure, I mean, in the future, Tesla might win this race if they want to compete in the UAV segment because, yeah, I mean, their self-driving cars with their batteries are all already, giving a lot of competition to other, creators. Right. So great point. Let's move on to something that we really wanted to talk about, in this podcast. A question that is really, close to my heart as well. Um, how do you feel being one of the few women in drone technology worldwide? And what are the challenges and opportunities it presents for especially women in this field?
Yes, so I actually looked up the numbers for Germany because I'm currently located in Germany, and it's about 70% of software developers are female. So this is like a very, very, very low number. So I can really say this for roboticists, it's even a little bit lower, but this is too few. This is simply too few, and it sometimes, yeah, really, I think it's a pity that I don't have more female colleagues.
Mm,
And I mean, we have multiple reasons for that, and really starting from stereotypes and goes until wrong expectations about the job or not knowing what this job is really about. And yeah, the question is, of course, what we can do about it as as developers, as society, also maybe to encourage more women to get into this field. And what I'm doing is I have two main points. So the first would be really the area of being a role model to other women in the technical area, so that maybe more women are inspired to change to this field or even start in this field. So what I'm doing is voluntarily giving coding lessons for children, so that the little girls see me, and maybe I can inspire them for a career even in AI. And that it's simply also that the children get in touch with technology at a quite early age, because at least in Germany this is not part of the regular school education. So they really need, there are organizations, maybe even encourage teachers, but they need some touch points with technique. So this is one part what I'm doing, and in the organization I'm working or volunteering, we have two formats. One open for children between the age of 10 and I think 19. So anyone can sign up there. And for some of these lessons, we close them so that they are only for girls and women. So everyone above the age of 10 can apply for these lessons, or every woman can apply there. And we saw that especially these lessons get a lot of attraction, and we always have full classes there when we're talking about AI and ML. And this is one point for me, really being this role model, bringing women in touch with technology. And the second point is networking, so that we really bring together the female technicians, so that they can exchange about the challenges they face. And what we also do is being part of regular female networks, so not only closed for technicians, but also encourage maybe other women to look at least in this technical field. So as you might know, in this industry we don't only have pure technical roles, but a lot of other roles too, so that more women can join here. And I think this is really an important part that at least I feel like I have to do to encourage more women for this field. And that's what I can also see not only happening in industry, but for example also in academia. At the tech conferences, sometimes there are special women breakfasts where women can connect and exchange with each other, and I think that's the way to go, and hopefully you will see more women entering this field at some point.
Yes, that's fantastic. Great job that you're doing, bringing in more women and girls into the field of tech, and especially into AI and ML. Commendable, quite commendable. And I wish you all the best. I hope, we have an equal participation and equal wages and equal opportunities for women as well. So I wanted to ask you, the field of robotics is something that is also getting mature in terms of getting adopted in real businesses that impacts normal people, everyday life of normal people. How powerful then are the autonomous robots carrying out tasks that are intelligent and that require complex interaction with the surroundings?
Yeah, that's a really, really good question. So, I mean, what we can observe is that robots are more and more used as co-workers for repetitive tasks, so for tasks unlike you described, so not so intelligent tasks. Just for example, bringing boxes in a factory from A to B, where we have our very, very limited operation area. We know how this looks like, and I think this is really the area where robots are currently bringing the most benefit, really as co-worker, helping people to take over repetitive tasks. Because in the end, it's still like the way how we program robots today is we as developer have to tell them explicitly what they need to do, and for that we are restricting it to a specific environment where they can work in. So when we're really talking about intelligent tasks, it's becoming really hard for robots to enter this field, because even when we're talking about AI and machine learning in particular, still we tell them what to look for with the data sets we provide them, with the objects we provide them, and they simply cannot generalize concepts. So we tell them what to look for, and they're looking exactly for those things. And at the moment we don't have anything like this artificial general intelligence. So it's really us as programmers, as developers, we are telling them what to do. And I think that's why we are currently see this limited area where we can really apply robots with benefit. And so this is really the part where we still need the human workforces, right? So this is really, we can take on the repetitive tasks, which we can lay off to the robots, but for the intelligent or intellectual tasks, we still need human, and this won't change in any time soon.
Okay. Yeah, that's a great point. The reason why I asked is that doing repetitive tasks are still quite okay, and robots are doing it for the last, I think, 2 decades now. What really matters is when you put general intelligence to it, wherein they start thinking about their surroundings, something like a autopilot, or something that needs your attention with the surroundings, wherein you learn from the surroundings. But you're right. I mean, you would still need a human to provide those data sets, those models for it to first learn and then implement it, and that's where all the complexity comes in.
Yes, and I mean, when we are talking really about the robots or even Industry 4.0, it's still the same. So the robots can really work alongside the humans, and even the environment can change. So it's not like this automation pipeline which we know for the past 2 decades. So I mean, they can interact with humans, they can drive alongside in the hallway, they can do a lot of things. But in the end, it's still the developer who programmed it. It's not like we let them out freely in the factory and they're learning magically from itself, or purely by imitation learning what they need to do. So this is something where I think until we get there, I mean, this is a long way.
Right, and that is what I was about to ask you. How do you envision it in the future? Like, is it 30, 40, 50 years from now that more intelligent robots will be around us?
I can't tell you any number there. What I really could recommend you, and I think this is a fantastic book also to read, is the 1,000 Brain Theory from Jeff Hawkins. And there a complete chapter is about this general intelligence. And I mean, I think as long as we haven't understood how our brain works, it will become hard to try to reproduce the behavior in robots.
You're absolutely right, yes. And in my podcast, in the previous episode, we have covered that part with a lot of AGI researchers as well. And they are also of the opinion that it's a monumental, fundamental shift in how we develop intelligence, because right now with weak AI or the narrow AI, it's more tool based. But when you want to make sure that the robot or the AI learns by itself, then you're not doing justice by just adding good lines of codes there. You have to understand how the human brain works in terms of philosophical parameters as well, and without that you cannot build a very robust strong AI. So, in robotics, what is it that is groundbreaking today, which will let us focus on more productive tasks? And since it is autonomous, it'll be able to perform more repetitive tasks of our daily lives or in the businesses. Just repeating myself from the last question, but what do you think is the most groundbreaking thing? Uh, yeah.
Well, I don't think that there is like something like a single or single thing which will break everything. So I think it's a
Right.
combination of a few steps which we are taking. So for me, when we are talking really about our working life, I see a huge benefit in this industry 4.0 and IoT topic when we are talking about factories where we can really use robots alongside humans. But because they're operating alongside humans in a human environment, so the question is if they really have a higher repetitive rate or less errors or failures than a human, or we can simply free human resources for intelligent tasks or intellectual tasks there. And I think this is the big benefit when you're talking about these cobots and working
Yeah.
alongside human. This is one aspect where I think we will see a few changes, a few adaptations in the future. Of course, as roboticist, I hope to see more and more robots coming into the area where it's simply too dangerous for a human. So when we really talk about search and rescue scenarios or maybe some emergencies in nuclear power plants, that we can send in robots there to not risk human life. So this is really something where I see also a big benefit of the robots. And coming back to our working life, when we are talking about this whole automation, making things easier, making good predictions, the way how we currently use tools with suggestions and ease the workflows, so that we don't, that we can get rid of these repetitive tasks and that people can really speed up at least these workflow parts. With the help of not only robots but really automation tools, pipelines, the way how we really process language nowadays, so that it's also getting more and more inclusive, the way how we currently use computers.
Let me ask you something then, connected to it. Like you mentioned about the nuclear plants, sending robots would be much better. Um, so, in terms of space science, how does robotics tend to help the civilization in terms of doing great discoveries or finding hidden rules of our universe by doing research on other planets or moons or yeah.
Yeah, I think there is simply no other option than using autonomous robots.
Right.
Simply, to all this hazardous environment for a human, especially when we're talking about Mars missions. I mean, we have no other option than sending robots there, and due to this really far distance, we even can't teleoperate those robots. So there is a need, or a strong need, for truly autonomous robots. With truly autonomous, I mean they need to survive there. I mean, they need to operate there for a few months before they are sent back, or before they can send back things to Earth. And as roboticist, really, when I think of letting a robot run for 3 or 4 months without a reboot, I mean, this is a really, really big thing, so that it's not getting stuck either in some kind of software loop, in a bug, but also then with all the mechanical things which we simply yet don't know how this planet looks like, what we need to think of, that it's not getting stuck in any stupid hole and then can't do anything anymore. So this is, for me, it's really interesting to see how those robots are designed. And
Right.
also the development, what they already sent there years ago with the past technology, and now what's available. So I think we can really be curious to see what we get back from space in a few years.
Mm. Yes, that's a great point. I mean, imagine sending a whole robot by itself, staying there for years on a planet, and sending data back to us. I mean, like you talked about the battery thing in the UAVs. How would you have a robot just run by itself by using solar energy, on the Mars rover? So, I mean, there are a lot of parts to it, and how we all collectively come together at NASA and other organizations to sort of build something like that is phenomenal. So, talking about nanobots or nano robots, and the shape changing robots, like, yeah, I've read there somewhere that there are shape changing robots as well, since they can fit into smaller parts where human hand or devices cannot reach. So, what are the criteria in building such robots, such finesse of building it? Is the speed to perform an action that a human brain and hands or legs can't perform, or is it the precision of not making mistake ever? What kind of criteria are put into it? Mhm.
I mean, I think it can only be a combination of all the aspects which you just mentioned.
Right.
So for me, when I think about nanobots, for me, in the beginning, immediately medicine comes into my mind, and all the great research which is done there with nanobots. And this is for me really, really interesting, but also a little bit far away from my daily work. So I think when we think of also these nanobots in terms of medicine, we have to get away from the thinking that this is a little mechanical bug which you swallow and then it crawls around into your body. But I mean, how it's completely different how they are designed. So I mean, you can't compare it to a mechanical robot at all. So they are using techniques to how this could be moved with ultrasonic sound in the body and bringing it exactly where the doctor is wanting the robot to be, or even really bringing the drugs especially to the part in the body where they want them to be. So for me, this is really kind of an art how these robots are designed, and I can't think of how they start with the design process at all, but this great combination here of technique, mechanical engineering, also medicine. I mean, this is simply amazing, and I'm really curious, and what we will see there in future and in terms of treatments and how precise those treatments could become. And of course, these robots, when we're talking about the human body, I mean, they have a complete different scale, and the precision they need to reach with these robots, I mean, this is so far off from the precision I need to reach with drones or UAVs. We are not talking about millimeters here, and if I really run the drone or land the drone with a millimeter precision, everyone is happy, and we are good to go, and we have enough space everywhere. But for the body, you have simply no space at all and no time to make mistakes. So in terms of precision, in terms of timing and controlling, I think this is really a complete different story. So this is, as I said, so a lot of research in this field, and I'm really, really curious what we will see there in the next 5 to 10 years.
Fantastic. Yes, absolutely great point. The kind of tech and the kind of design, the kind of art, like you said, is used there is phenomenal. How a small nano robot or nanobot is sent inside the human body to treat certain things, and maybe even outside of healthcare, there are some more applications of it in farming. They're using it as a drone, small drones, like bees and others, and phenomenal things. Yeah.
Yeah, also one application which I just read about an Austrian startup is also to clean the drains and tunnels, where you can put in robots and being much faster than humans who need to open up all the different pipes and clean everything, but also from this perspective, I mean, it's simply so much faster, and it's so beneficial to use it here. I think we'll see a lot of different applications with small-sized robots as well.
Right. That's a great point. In all kinds of applications, not just healthcare, but agriculture, and like you said, usage in trains, airplanes, everywhere. Yeah. Since we discussed about robotics and how some of them could be groundbreaking, one of the humanoid robots that I have came across and I wanted to talk to you about it is Ameca, Ameca. So, what kind of artificial intelligence is used in building it, and what is your thought about how it can change how we see robotics? How is it possible to teach complex dexterity using AI simulations?
Yes, so I mean, for me, these humanoid robots are really also, I think, one of the most complicated robotic systems you can think of in terms of development and complete interaction. And I mean, they are really built to interact with humans. And for me, this is a super difficult part. So when you're just talking about the interaction with humans, all this natural language processing, so understanding different people, understanding different accents or dialects in a language, and then processing the meaning and giving clever answers, just this part on its own is already challenging and difficult. When you now look at Ameca, they not only have then a sound output, but they're also doing gestures. I think they have something with the glaze, so the eye movements when it speaks. So it's even much more difficult to learn this behavior or program this behavior. Probably they learned it from watching human interactions. This is already one big topic, and we are not talking about the robot moving at the moment. So I mean, it's a walking robot, and for this walking behavior, when you think of the controlling of the legs, that it's not falling over, I think most of the listeners have seen the first Now videos when they start to walk or always constantly fall over and over and over again. I mean, of course, there are reinforcement learning algorithms which you could use to learn such a behavior, but it's still a huge pile of work to make it working that nicely. And now we are talking about, okay, we have a robot, the robot can move, the robot can also move the arms for the gestures and interact with the voice. But the robot is not, at the moment, when you're thinking of, it's not doing something meaningful. So usually the acceptance of robots for human starts to raise when it's doing something meaningful. Now imagine just setting up the table for dinner and letting a robot doing that. Having all these interactions with this human environment, manipulation, perceiving the environment, finding the right parts like the tables, the cutlery, putting it there. Again, a complete different challenge, and from the robotics part, it's super interesting because there are so many different aspects and you need experts of all the different fields, like from perception to human interaction, NLP, controlling. It's really interesting project. And I think the big benefit of those robots could be really the interaction with other non-technicians to get this acceptance of the robots, and also to understand where the limitations are. Because if you're speaking to such a bot, you see that, I mean, this is not general intelligence. You can't have a clever conversation with this robot. You might ask him to perform task A or task B, but really seeing this limitation, I think, would take away a lot of the fear from robots from people also. So that, I mean, there is no chance that this thing will take over the world or rule the world. And I think seeing this live in action, where the limitations of robots are, is really important for the broad public also to see.
So is Tesla, because its AI is also top notch in terms of autonomous pilot and then computer vision and everything that they do to make sure that self-driving works. So, as for you, is Tesla the world's most successful robotics company? Because basically they have a semi-sentient AI placed inside their cars. What, according to you, is it?
For me, it's hard to call something the most successful robotics company in the world,
Right,
um,
right.
based on which criteria. What I really admire Tesla for is really how they built or they started off with building electrical cars, how they convinced, I mean, at that point when they started, I think everyone was against electric cars. No one could imagine using electric cars. And they managed to build up a complete company just on their beliefs that this is the next thing to happen. And for me, this is really also the big story of a startup, which is disrupting or transforming the market. Because if Tesla wouldn't have been there, I don't know if so many car manufacturers would have electric cars right now. So I think this is really from this perspective, it's really admiring how they build up this business, really with just strongly believing that this is the right thing to do. And this is really the big positive aspect here. And just for this, yes, it's a complete success story. If it's the most successful, as I said, so it's hard to tell. From a robotics perspective, when we are talking about Tesla's autopilot, for me this is a little bit more difficult, because first of all they call it autopilot, but when you take a look at the autonomy levels, when it comes to autonomous driving, it's probably something around level 2, maybe level 3, which means that in the end the driver is completely responsible for taking over if something happens. So the software is not taking responsibility. So if it says take over, you have to immediately take over. You don't have much time to say, no, I want to finish reading the newspaper article, so you need to take over immediately. So that's for me the gap between calling something autopilot and being level 2 is at least difficult, let's state it this way. And from then continuing with this autopilot software, I mean, I think currently they're only using camera and radar sensors, and they want, or at least there are rumors that they want to switch to camera only systems, because they strongly believe that driving with cameras only is the way to go. And that's where I have a different opinion on, because for me, when I'm working with robotics perception, I really need this multi-modal sensor setup. Multi-modal means I have different sensor types, because each sensor has its own pros and cons and works in different environments. For example, the camera is, as you can imagine, it's working good at good weather conditions. You can see far, you can see objects like we as humans do. But for example, if it's getting foggy, then you just have a white wall, you don't see much with the cameras. So that's where the radar hits in and could really predict or see objects which are beyond this fog wall. And I mean, there we could even become better than humans in predicting objects. Okay, be careful, there is something in 50 meters, in 100 meters. And this is something I can't follow, or I can't understand why they are kicking out this multimodal sensor approach. And I think they're one of the few companies who are doing that. And yeah, so for me, this is really the difficult part here. And yeah, it's quite famous that they don't want to use LIDAR. And for me, this sensor, which really gives an accurate 3D representation of the environment in measuring real distances to other objects, this could be a big benefit in the planning and the perception, in really estimating how far objects are away. And in combination with the radar, which can directly measure the velocities, plus the camera in detecting all the visual signs which are set up for humans, for me this would be the perfect combination. And yes, of course, then talking further about all these IoT environment infrastructure sensors which warn cars about accidents, about things on the street. I mean, this is then the next step. But just for the status quo, for me, the only meaningful setup for truly autonomous car, so truly, let's talk about level 3, level 4, where you really have time to take over as driver, you need the sensors at the moment. For me, I think it's I can understand that you want to get rid of the sensors in terms of cost cutting, so not using it, and it's also from a system perspective, it's always easier if you don't have too many sensors inside, or different sensor types, but you're losing so much on the perception side. And for me, this is, as I said, something I can't understand. I mean, they have the reasons, probably a good reasons why they are following this approach. But so this is something I wouldn't feel comfortable to sit in and really use the level 4 autonomy functions in there.
Once that happens, when they bring the level 4 autonomy, would they require more technologies like LIDAR and multi-modal sensors around the car, or do you think that they already possess some kind of technology to replace it, but because of business pressure or because of the fact that we've seen that their cars have done so many accidents while doing the test pilot for all these, so they might be scared about the fact that why would we launch it when the market isn't ready for it? So what is your opinion of that?
Yeah, so I think just from the complexity, what we currently see, I think autonomous cars are promised now for more than 10 years, probably, something around,
exactly.
Probably
right.
10 years.
Right.
I think the complexity was simply underestimated in the beginning. So when we are talking about really low-level autonomy, really assistance, when we see this ACC, so this automated cruise control, where the radar keeps the distance to your car in front and just follows the car. I mean, this is one story which could be implemented. You still have the driver being full aware of the scene. And the step then to going to autonomy, level 3, level 4, I think this step or this gap was really underestimated. So I think all manufacturers will provide something like traffic jam pilot, something like this for the highways, which goes up to a certain velocity, where it simply supports the driver in the driving scenarios which they usually don't like. So I think this is also one big topic, especially when I am thinking of German car manufacturers. So I don't know if you know, but in Germany, the cars and the highways and also having the speed limit is really a thing. And
Yes.
yeah, having this pleasure during driving, I think this is also a big selling point for these cars. So I think we will definitely see something like an autopilot for these traffic jams, because this is also something people don't enjoy and which is really exhausting. This is something I can imagine, but how far they then go for this autonomous, real autonomy, I can't tell if it's meaningful for regular passenger cars, or if we then see the move to new mobility concepts like people mover shuttles, or some special setups which are really this car sharing inside the cities. So this is something I could imagine more from the business perspective, that we see then, once this traffic jam pilot is resolved, we see also a move more to this urban mobility concepts here. What I could imagine is, when we're not talking about passenger cars, but really about trucks, that we see more and more autonomy also in these vehicles, because I mean, overall they are much more expensive, so there might be a different also aspect in bringing more sensors in than in small passenger cars. And I mean, they are mainly driving on highways until they get to the urban parts where they deliver the goods. But I think, so if I should make a bet here, we will see these traffic jam pilots and then hopefully seeing some new mobility concepts in the urban environment.
So, what is your opinion of the simulation theory? Our favorite Elon Musk has said it some time back, and he said something about the simulation. We might be living in a simulation. Will we ever be able to live in a completed simulated reality using a VR headset? Because, or just a device which is sort of magnetically connected to our brain peripherally. The reason, as per me, this is so interesting is that there are now games so accurate and so high definition that if we play it using a VR headset, they are completely indistinguishable from reality. So then perhaps the only thing left to do is to add emotions using a device to my brain to feel all those impulses like in a natural environment such as ours.
Yeah, also really difficult topic also to talk about, or when we start thinking about it. So I mean, what I definitely can say is that's also what we see in this past 2 years now, being a lot at home, not having this social interaction, all the conferences being virtual, not meeting our peers. I think we can all say that humans are real social, or have real social habits, and want to meet people in person. And it's not only about seeing these people, but it's really about this interaction, communication, this non-verbal communication, even just shaking hands, touching other people. This is something which I think we all learned in the past 2 years, that we are missing this kind of interactions. And if you would have asked me 2 years ago, I might have given a different answer than now. But I think, based on this experience, this social interaction and really meeting in person, I can't imagine that we won't ever really kick this out or get rid of it and live in a purely simulated environment. So this is for me impossible I think this is simply not going to happen, but maybe I'm completely wrong. Regarding the simulations, I mean, yes, they are looking really realistic, and that's what we are also using in machine learning to train our models. I mean, this is a really good thing and has a lot of benefits in this aspect. But I can't imagine that just having a device inserting emotions or what we are about to feel, that we can learn this without having experienced it in the real world, and B, that yes, I have the impression that people are really tending back to the social events, to the social happenings, because we want to meet other people. And yes, of course, the question is how well can we simulate these feelings and emotions which we have when we meet other people? At least with the current technology, no, not at all. No way. Maybe we will see something in future which could do that. But just speaking of myself, at least, yeah, having this experience from the past 2 years, I can't imagine that I want to live in a purely virtual environment for this social interaction. Having this real simulated environments and all this virtual reality, it brings so many benefits to other aspects. When we are talking about therapy, about really bringing habits and physical training, and there are a lot of benefits for the simulation. But I think the only point which we can't get in there is this really social interaction.
And then Elon Musk is also building Neuralink, so sort of a device which will fit into our heads, which will allow people who have Alzheimer's, or people who do not have memory because of some accident or something, that can be recalled, or that can help them understand their world better. So yeah, I think you're right. There will be good applications of it as well in the future.
Yes, definitely. So they're the area also talking about also diseases affecting the brain. There we see a huge range of positive applications which such devices are really needed for. And yeah, as I said, so I'm really curious to see what's coming up in the future with new technology.
So then I think I've exhausted all the questions that I have this time for you, Julia. Before we wrap up, do you have any parting thoughts for us?
One part where we can, as a technical community, can really make a difference. So I think we are really on the cutting edge research and developing super cool new robots with a lot of helpful applications, and really bringing in this technology to help people. The issue I see is we are developing these applications, we see the benefit, but if people don't want to apply it, we have developed it, for nothing. So I think it's kind of our common responsibility not only to develop this technology, but also to explain it to the people, democratize all this knowledge of how we are building it, so that people are not afraid of this new development, of these new applications, and really also are as curious and as positive about these new developments as we are. And I think this can only happen in a collaborative way, and also really starting to explain the technology and not limiting to the few people who, did a master's or PhD degree in machine learning, but really spreading the word, making courses, explaining the technology, and really give the people the room and the chance to ask all the questions they have about this technology. Yes, because I think if you don't understand how it's working and really have no clue and can't get your head around it, it's also kind of natural that you are afraid of it, that you reject it. And I think that would be a pity. There we are really missing a big part for the future.
It is not just from the tech side, it should be a holistic support from everywhere to be able to allow these technologies to evolve. And this is precisely the reason why I have actually started the podcast, uh, is to make people more aware about what is going on in AI and the tech world, so that tomorrow, when the AI and the tech will penetrate into all of our lives, which it has already done. I mean, we already keep our smartphones with us. It's it's pure tech built. So I mean, there's so many examples. So I mean, if we want to live with it, and we have to live with it in the future, then it's great that we should support the people who are building it for a good cause, for uh, for the technical community. And I think, but then on the other side, Julia, there will be people who will be spreading all these nonsense conspiracy theories about, technology taking us over and AI taking us over and all that. But I mean, yeah, the good people just keep doing it.
That's a really, really good point too. So I think we also have to live with people just rejecting, for whatever reason,
Right, right.
just rejecting this technology. And I think this must be also something simply being accepted.
Yeah.
Um, the only thing which I can't accept is spreading wrong theories and some conspiracy theories about technical parts which are simply wrong. I mean, there is no way to go. But I think if we are really providing this open room for discussions, or at least let's state it this way, I like to think or have the naive idea that if we provide this room, if we do provide this education about the technology in terms of we give the room for questions, we help people understand, show them the benefits, that people will more and more get used to it and also use it. And then these people who spread the conspiracy theories, that they don't have any room for their theories anymore, so that we really take all the room with educating, being open, accepting different opinions here. So this is at least my hope.
Absolutely, you're absolutely right. And that is where the thing that you're doing about bringing women together in this cause is just phenomenal. It should be supported everywhere in the world, because it is the girl child that needs to come up and need to be taught and need to be encouraged to participate more in the tech world, because that's going to be our future tomorrow. So yes, I mean, kudos to you and to your efforts.
Thank you. Thank you. And
Yes.
yeah, great for you hosting this interesting podcast.
Right, fantastic. So thank you so much for your time, and you have a great day. And hopefully, in the future, we can schedule some other rounds where we can ask you some more questions on robotics.
Sure, sure. Please go ahead. Thank you
Yes.
for having me and this really, really interesting discussion. And have a nice afternoon too.
Thank you, Julia. Bye bye. Thank you for listening to this podcast. Please support this podcast by liking, commenting, sharing it with your friends, and also subscribing to this channel. Thank you, and we'll see you next time.